This QuickLearn Bullet introduces FX outright forwards, their quotation conventions, and their pricing methodology, familiarizes you with forward points, analyzes the sensitivities of forward contracts to movements in FX spot and interest rates, and examines FX par forwards. A forward FX transaction involves the exchange of currencies at an agreed rate for a value date other than spot. The standard forward periods are known as fixed or straight dates and have the following maturities: 1 month, 2 months, 3 months, 6 months, and 1 year. Any value date that falls between these periods is known as a broken date. In the FX market, dealers prefer to work with forward points instead of forward prices, because these often remain quite stable even when the spot rate is experiencing fluctuations. A typical screen showing spot prices and forward points appears now. When the forward points are quoted in ascending order on the screen, as you can see in this table here, the forward rates are equal to spot plus the forward points. In this case, the forward rate is said to be at a premium to spot, meaning that the forward rate is greater than the spot. Conversely, when the forward points are quoted in descending order, as on the screen here, the forward rate is calculated as spot minus the forward points. In this case, the forward value is said to be at a discount to spot, meaning the forward value is smaller than the spot. Suppose you wish to calculate the 1-month forward bid rate for euro-dollar. Because the 1-month forward point quote of 26.526, as you can see here, is in descending order, you must subtract the 1-month forward points bid rate from the spot euro-dollar bid rate. It is necessary when doing so to align the digit to the left of the decimal of the forward points quote directly underneath the last digit of the spot quote, as you can see here. In this case, the 6 from the 2650 must be aligned directly underneath the 8, the last digit of the 1.5628 quote. This yields a forward bid rate of 1.56015. Conversely, if you wish to calculate the 6-month US dollar Canadian dollar forward offer rate, where the 6-month quote of 16.25/16.80 that you see here is in ascending order, you will need to add the forward points offer rate to the spot dollar CAD offer rate. Here again, you need to align the digit to the left of the decimal of the forward points quote directly underneath the last digit of the spot quote, and this yields a forward offer rate of 1.07958. The exact formula for pricing an FX forward, which takes into account each currency's day count convention, appears here, where RT is the term currency interest rate, RB the base currency interest rate, and where we would use 365 in lieu of 360 if necessary. We now price using this equation a 6-month euro-dollar forward when spot is 1.44. The 6-month dollar interest rate is 2%, and the 6-month euro interest rate is 4%. We also assume that the exact day count for the 6-month period is 181 days. For now, we ignore bid offer. You can confirm on your own that inserting the above data yields a euro-dollar 6-month forward rate of 1.4258. This, of course, also enables us to derive the 6-month forward points simply by subtracting the spot rate from the forward rate to obtain 142 points. Note that the forward is trading at a discount to the spot here because the euro interest rate, which is the base currency interest rate, is greater than the dollar interest rate, which is the term currency interest rate. In this situation, a dealer who establishes a long euro 6-month forward position against the dollar could now borrow euros for 6 months at a 4% rate while lending dollars at 2%. This borrow and lend position would be fully hedged by the forward he has entered into, with the cash flows from the forward being offset perfectly by the cash flows at maturity from the repayment of the loan he has made and the maturing of the borrowing he has undertaken. It is of course necessary to assume that the amounts of the investment and the loan are set to be exactly those amounts that would perfectly offset the cash flows on the right. The specific amounts in each currency that he would borrow and invest have just appeared. The euro loan would have a principal of just over 9.8 million and would incur interest over the 6-month period, applying the 4% interest rate of just under 200,000 euros. The US dollar investment he has made would have a principal of slightly more than 14 million and would earn interest of just under 142,000, representing the 2% dollar rate applicable over 6 months. Since the dealer is borrowing at the higher rate of 4% and lending at the lower rate of 2%, he would be paying a differential known as the negative carry of 2% on the notionals. This is reflected in the table we showed previously and which we reproduce here by the fact that the 6-month forward rate on the euro dollar is quoted at a discount to spot. By the same token, consider a dealer who establishes a short euro 6-month forward position against the dollar. Reversing the hedge from the preceding situation, this dealer could now lend euros for 6 months at 4% while borrowing dollars for 6 months at 2%. This borrow and lend position again would be fully hedged by the forward he has entered into, with the cash flows from the forward being offset perfectly by the cash flows at maturity from the repayment of the loan he has made and the maturing of the borrowing he has undertaken. The dealer is therefore earning the differential, or the positive carry, of 2% in this instance. This would be reflected by a short sale of the euro-dollar forward at a discount to spot. Using our prior euro-dollar example, with spot euro-dollar at 144 and US and euro 6-month interest rates at 2% and 4% respectively, we now consider the situation where a dealer goes long 6-month forward euro dollars at 1.4258 on a notional amount of 10 million euros. An investor holding this position would have a gain from a move up in spot and a loss from a move down in spot, while an investor who is short euro-dollar forward would have the opposite result, i.e. a gain from a move down in spot and a loss from a move up. We now examine how the forward rate is impacted by movements in the interest rates for the base and term currencies. Using the outright forward formula again, we can derive the formula for the forward points from the definition of the forward points as the difference between the forward and the spot. After rearranging the terms, we get this expression here. We next assume that the spot remains constant and that it has the interest rates that fluctuate. Movements in the base currency interest rate would, it is true, have some impact on the denominator of the formula, but this impact will be small in comparison to the impact on the numerator, which will be discussed shortly. For the sake of simplicity, we therefore assume that the term in the denominator remains constant and can be ignored, as the base currency interest rate changes. This leads us to the conclusion that the forward points are principally affected by movements in the differential between the base and term currency interest rates. So as the interest rate spread tightens, the forward value increases, and conversely, when this spread widens, the forward value decreases. Therefore, the dealer holding a long euro-dollar position would gain from a tightening of the interest rate differential and would lose from a widening of that differential. The opposite would be true for an investor holding a short euro-dollar position, i.e. he would lose from a tightening of the differential and gain from a widening of this differential. We conclude this QuickLearn bullet by describing the pricing and use of an FX par forward. Suppose that on September 16, 2005, a US company completed sales to a Brazilian company and that the Brazilian company has promised payment in 4 equal quarterly installments of 10 million Brazilian reals each. The US company would like to lock in a definitive exchange rate for each receivable to eliminate its exposure to fluctuations in the exchange rate. The company could simply execute a series of 4 long dollar real forwards at the prevailing rates for maturities of 3 months, 6 months, 9 months, and 1 year. Here we assume that the dollar interest rate is 2% as before, the real interest rate is 12%, and the dollar real spot is 2.15. Using the outright forward formula, we can calculate the forward rate for each maturity as can be seen in this column here. Due to the large interest rate differential, each successive forward rate becomes weaker than the one preceding it, resulting in net dollar cash flows received by the US company that diminish sequentially over each quarter and by a substantial amount. The treasurer would logically prefer to see a single forward exchange rate at which she could exchange all her Brazilian real receivables. The par forward solution makes it possible for her to smooth out the uneven dollar cash flows that would result from using the outright forward rates. And it is constructed simply by solving for the single rate that would generate cash flows in US dollars, whose present value appropriately discounted equals the present value of the unequal stream of cash flows. The following 2 slides will illustrate this process. This slide shows the forward rates, the real receivables, and the equivalent dollar receivables under these forward rates. You will note the diminishing dollar cash flows as mentioned previously. The next column now shows a smooth pattern of dollar cash flows based on a guess that the par forward is 2.5. The column after that shows the difference between the cash flows in the original column and the smooth column. And this final column shows the PV of these differences, currently summing to just over $1.5 million. On this second slide, the dollar receivables under the par forward have increased to the level at which the PV of the difference we had just examined is now exactly 0. You will observe that the par forward rate has decreased to 2.2820 versus our original guess of 2.5. Therefore, instead of going long dollar real outright at the individual rates shown in this column here, the treasurer has locked in a long dollar real hedge using a par forward rate of 2.2820 for all 4 value dates, resulting in smooth dollar-denominated receipts on a quarterly basis. This concludes this QuickLearn Bullet on FX forwards.